our first speaker today. We talk about how auto-scale MongoDB. And it's actually a very interesting topic for many customers that are using the cloud and not. Please, a warm welcome to Ratika Gandhi.
Thank you. Can everybody hear me? Awesome. Good morning, everybody. One of the most favorite parts of my job at MongoDB is that I talk to a lot of customers. Sometimes I talk to developers building brand new applications, and sometimes I talk to people managing enterprise-grade applications. And there's one thing common between all of them, and that is they're always thinking about scale. Almost always, scale is top of mind. The person who's building a brand new application is thinking about what happens if I wake up tomorrow and my application is an overnight success. Will it be able to handle it? And those managing enterprise-grade applications are thinking, hey, how do I prepare for this big launch of the year? How do I prepare for the next million customers, for example? And there's a lot that goes into managing your application to scale gracefully, and a lot of reasons for why your applications scale. And that's why we're here, to talk about essential MongoDB scaling strategies. I am Ratika Gandhi. I'm a senior product manager in the core database team of MongoDB. I focus specifically on sharding. So today we're going to talk about, okay, clicker's working, why applications scale, what are some of the existing ways in which MongoDB can let you scale your application, and what we've been up to this whole year, collecting feedback and working relentlessly on, opening up new ways in which you can scale your application. And in the end, I'll leave some time for Q&A. So let's dive in. Why do applications scale? One of the main reasons for applications to scale is that you're doing more complex things now. You're running complex aggregations, you're running complex transactions, and there's not enough processing power you provided. So now you started on a 2 CPU machine, but because you have so many users and you're doing so many complex things, you need 4 CPUs, for example. Or next you'll need 8 CPUs or 16 CPUs and so on and so forth. So you need more processing power for your application. And that's one reason to scale. The other is RAM. As your data grows, you need more RAM. Why is that? Because in MongoDB, we recommend that you have a working set, which is your indexes and your frequently accessed data available in memory, so that you don't have to go to disk and your application performs better. So the more data you have, the more RAM you need. And say you started at 32 gigs because you thought, hey, I don't know, maybe I don't need to pay so much money. Let me see if my application's actually working. And it works. So you need more memory. Then disk throughput. So this is something not a lot of people usually think about. Not only do you want every operation that goes to disk to be fast, but you also want your disk to be able to handle a lot of operations. And that's where you need disks that have a high throughput. And last one, this is an easy one to understand. You just have so much data that your machine is not able to handle it right now. So you need more storage. And there's many different ways to handle each of these. One of the easiest way to do it is vertical scaling. So you start on Atlas or an M30 machine, for example. You quickly notice that, hey, you're running out of resources, so you need more resources. So you either click the auto scaling button and Atlas will manage it for you, or you say, hey, give me a tier up. So you go to an M40, and now you have 4 CPUs, 64 gigs of RAM. So you're happy, but you need more resources. And so you say, okay, screw it, give me an even bigger machine, and now you have an M80. And then you keep scaling up as your application needs more resources. There's a couple of downsides to vertical scaling, even though it's as easy as a click of a button or just procuring the next big machine. There's a couple of downsides. And those are essentially, it's expensive. You need more resources. They don't necessarily scale linearly. They'll almost always double in size. So you're paying a lot more, even though you might need just a little bit more resources from what you have today. And then, of course, you might hit a point where you'll actually hit the limits, the physical limits of what a machine can do. So you can no longer fit your data onto the biggest machine available in the market, for example. So what do? Then you look into horizontal scaling, or you can look into from the very beginning, my bread and butter. How does horizontal scaling work? It's pretty simple. You essentially, start with a single machine. Now you need more resources. Instead of going up a tier from M30 to an M40, don't do that. You add another M30 to your system, so another shard. Now you need more data and more resources. So you add another M30, and you keep going on and so forth, depending on your application's needs. And you can keep scaling by adding more and more shards to your cluster. But how does this work? Do you put, what are you putting on these additional shards? So horizontal scaling is nothing but dividing your data to live on multiple machines. So here we have an example of a drivers collection. This collection is growing rapidly because a lot of drivers are joining your application. And now you decide that, hey, I want to scale this horizontally. That's the strategy I'm going for because I expect a lot of growth and I always want to be prepared for growth. And so what you do is basically you want a part of drivers to live on shard 0 and the other part to live on shard 1. So you run a simple command called shard collection, taxi.drivers, and provide us the key that we should divide the data on. So if you tell us, hey, divide my data on driver's ID, half of your driver IDs will live on shard 0, and the other half will move to shard 1. That's a native MongoDB operation. You just run shard collection. But you have to provide the key here. Like, you have to give it the information on what shard key should we be dividing your data. And that's not always easy. If your application is built in a way that all of your reads and writes are pretty much using a single field or a set of fields, then you know that's the key to shard on. But if your application is more complex than that, it's often hard to find a good shard key. And that's why in 7.0, we released a shard key analyzer. A good shard key not only lets you spread your data out evenly, but also facilitates your most important queries. And for that, basically, it's a two-step process. You run configure query analyzer. And what it does is something very simple. It'll just sample queries. Reads and writes that are coming in will be sampled and stored in a collection that will have a time to live of 7 days. And here, like you see, we've said that, hey, sample 5 queries every second. You let it run a couple of days, depending on your workload, even more if you have variable workload. And we keep sampling in the background. Once you've sampled enough queries, then you provide it driver's ID, for example. You're like, analyze driver's ID as a shard key for me for this collection. What analyze shard key will do is give you information about the characteristics of your field. Is it a monotonically increasing field? Does it have high cardinality? What is the frequency of that particular field in your data? And is it unique? It's often hard to know this information about a field up front if you've not been the one who's built that application. And apart from this, it also gives you information about your read and write distribution. So are you sending a targeted read, or are you sending scatter-gather reads and writes, which is basically every read and write is going to every single shard. What is the percentage of your multi-shard reads if you used driver's ID, for example? And then it goes a step further for your writes to tell you, if you used driver's ID, then you'll have X percentage of your queries that will not even have the shard key. So all of that information arms you with understanding what is a good shard key for your application. Let's take another example. So you've already sharded drivers. A part of it is living on shard 0. Now you want to shard riders. So you configure the query analyzer. You then run analyze shard key for riders. You try different shard keys, riders ID hashed, or trip and rider's ID combination. And then you come to the conclusion that, hey, rider ID hashed is the one that I need to use. So you give a command, shard collection, shard key, rider's ID hashed. Now MongoDB will basically spread your data equally on shard 0 and shard 1. That's the native way to do scaling. You either go from a small machine to a big machine and to a bigger machine, or you keep adding more machines of the same size, and MongoDB manages that for you. What we've been up to in the last year is we've heard a lot of feedback from our customers, and we have expanded the ways in which you can use your horizontally scaled cluster. In this particular, what we're doing here is basically allowing you to move your unsharded collections online. Let's see how this works. So you have drivers and riders. We'll continue with the same example on shard 0. And you notice that, hey, riders are growing, drivers will also eventually grow. So I can shard them, but I'll have to go through the work of finding a good shard key and managing, managing the overhead of sharding. So instead, wouldn't it be cool if you just were able to move riders on its own shard, for example, or drivers on its own shard? Because you're ready to pay for another machine, you don't want to partition your data just yet. So in 8.0, that's possible. You can move drivers to a machine of its own by running a simple command called move collection, where you provide the namespace, which is taxi.drivers, and which shard you want to move it to. So in this case, you're saying, hey, move this collection to shard 1. So MongoDB will move it to the shard of your choice in the background. Let's look at another example. Often shard 0 is going to be your primary shard. So there'll be a lot of unsharded collections on your machine. And in that case, what would happen is you would want to, now you're saying that, hey, a few of these collections are growing a lot, but a few others are not growing as much, but they're all competing for resources on this one shard. So why don't I add another shard and move some of these collections to that shard? You can do that now in 8.0 by, again, running the same move collection for E in this case, and you provide shard 1. So we move E. Then you run move collection F, move collection G, and move collection H to move them one by one to the shard of your choice. In this example, you could also add 8 shards and have one collection live on each of them, if that's what your workload needs. So what does it provide you? It provides you speed. It is an online operation and a fast one. We've been working on improving the data movement speed at MongoDB in the last couple of years. You've seen resharding, you've seen a new version of it come up, you've seen a new version of resharding come up, which is faster. And now in 8.0, it's even faster. So it moves your collections pretty quickly. There's no impact on your workload. The collection, you can continue to use your application like you did before, and you shouldn't see any impact on your application at all. And lastly, you don't need to make any application changes. Your shard key, you don't need to worry about that just yet. It gives you some time to leverage scale in a way that hasn't been possible before. And some of you who are familiar with sharding or have used it are probably wondering that, hey, you know how you couldn't move collections before 8.0? What I happened to do was shard a ton of my collections, because when I sharded one big collection, I had to add all these machines to my cluster. And they were all sitting idle in terms of the resources that it had. So I decided to shard a lot of my collections so that they can all each live on those additional shards. What do I do now? I don't really need them sharded. Do I get an option? You do, yes. We did think about you, and in 8.0, it is possible to unshard a collection. So in this example, we have riders and drivers both sharded equally on shard 0 and shard 1. You decide that, hey, riders is fine, let it be sharded for now, but I want to unshard drivers because there's a change in your application pattern, for example, and so you don't want to manage you don't want to manage it, and you want to move it all to one single shard. And it's possible by running a simple command called unshard collection taxi.drivers and provide us the shard you want to move it to. So here you're saying that, hey, move it to shard 0 as my shard of choice for drivers. Now you're like, okay, this worked, this is great. Now I will do the exact same for riders. I will move my riders collection to live on a single shard. And for those of you familiar with sharding, I want to call out that you can do this with zone sharding in 7.0 and prior versions also. But that requires, again, like an overhead of managing your application, managing your collection to live on a single machine. But you don't want to deal with that. So now you have an option of unsharding your drivers by supplying the same command, unshard collection taxi.riders. You'll notice here that I have not provided the 2-shard value. That's because if you don't provide the 2-shard value, we will pick the least loaded shard for you. But if you have a specific preference and you want that collection to live on a particular shard, you can provide the 2-shard option. Once again, this is a very fast operation. This does not have any impact on your application because we've just improved the way in which we do inserts of this collection on the shard of your choice. And you don't have to make any application changes. You can continue using your queries like you did before, and now the collection will appear on the shard that you provided in the command, or the least loaded shard. So essentially, in 8.0, two new things that we've unlocked in terms of scale is moving your collection and unsharding collection. Now, you remember how I mentioned that a lot of you probably sharded a lot of collections because you had to have a cluster, which was, if it was an M200, if your replica set, and you wanted to add more shards to it, to shard one collection, you could only add more M200s. And that's why you had to shard more collections, and that is an expensive operation, of course. It has a pretty high cost associated with it because now you're paying for your hottest shard, hottest tier of your shard for the entire cluster, which can be pretty expensive. And so what we've done, and we've listened to your feedback, and we want to make things easier for you, is that now available already is an option to scale your shards independently. What you can do is, if you have an M200 replica set that you're converting to a sharded cluster, for example, you can add M50s, for example, in your sharded cluster, because that's how much resource your sharded collection will need. And say you add 3 M50s in your cluster. Now you realize that your shard 3 is kind of becoming a hotspot because maybe you have more databases on that shard. Maybe the distribution is such that it is becoming a hotspot. And what you can do in that case is scale just shard 3 independently. And now it becomes an M80. So you're able to scale every shard independently in your cluster, and we're calling that independent shard scaling. I have put a caveat here, which is same storage size. The shards still have to have the same storage size. So let's talk about what you can do with independent shard scaling. Independent shard scaling unlocks your ability to optimize cost by only scaling the shards that need to be scaled. It also lets you customize IOPS. So if you want standard IOPS on a single shard, but you want provisioned IOPS on a shard that is hotter, you can do that. And this feature is available on Atlas Admin API, CLI, and Terraform. We like this feedback so much that it is actually available on all the supported versions of MongoDB in Atlas. If you did use autoscaler, I want to add that that's also supported with independent shard scaling. It's just that autoscaler will basically make sure that your collections, that your cluster tier, the difference between the cluster tiers is maximum of 2. But without that, if you don't want autoscaling, you're free to size your shards the way you like. So recapping, what have we learned in this presentation about what's coming up and what we've been up to in this last year is you can now move unsharded collections to a shard of your choice. You can, like I said here, move E, F, G, and H individually to shard 1 by running move collection and providing the shard that you want it to be moved to. You can unshard collections in 8.0 by simply running unshard collection and providing us the shard if you'd like to. We create the collection once again onto the shard of your choice, and it's seamless, it's fast, and it does not require application changes. And lastly, you are able to scale your shards independently, which unlocks your ability to optimize costs and only pay for the shards that really need those resources, as opposed to the entire cluster. And with that, I'm going to open up to questions. Yes.
Wait a second. No. Hi. Morning.
Hi, my name is Srinivas. I'm from Barclays. My question is, the first 2 features that you explained, I'm assuming it's on enterprise as well, not just Atlas.
Correct, yes. They're available on-prem.
And second, are they reliant on the balancer scheduler, or is it just going to be like live resharding which works in the background?
The latter. It'll be like live resharding which works on in the background, yes.
Anybody else? Oh,
Yes.
There you go. Coming.
Hello, my name is Bettina. I'm from Goldman. I had a question about change streams. If this new solution affects change streams at all, because we have found that change streams are slowish, essentially, especially with multi-sharding solutions. So I'm wondering if that is a way to reduce the latency of them.
Which one specifically? Move collection?
Move collection. Basically, if you have the collection on a single shard, but you're able to basically scale by having multiple shards, each with one collection, does that improve the change stream latency?
So yes, basically it'll have the same latency like you would have for an uncharted collection. But because you're on a sharded cluster, the change streams will still have to have a hit on the config server. So not as bad as for a sharded collection, if I may, but better because you'll have all of your data on a single shard. So you're not waiting on change streams from other shards.
Hi, my name is Tamás from Featurespace. Quick question on independent sharding, very welcome. Why this size cannot be changed independently? Because, for example, for us, we have lots of call data, which extremely huge, so those can be in one shard.
Right.
And the rest would be, the fast data can be on high IOPS nodes.
Right. So yes, but the storage size has to be the same. But why? Oh, it's just that it is a lot harder to build for asymmetric storage size. So we've started with this particular feature, and we're evaluating if we can get to asymmetric storage sizes.
Any other question? No?
Anybody else?
Well, please, a round of applause for Ratika.
Thank you.
Thank you, Ratika.